Howdy.
Brought Old Faithful with you, didn't you?
Where y'all want it?
Anywhere you want to set it up, it's fine.
On the fourth. Thank you. Yeah. That's just loose. No, right there. Oh, Michael, you think too much.
But you can just take it off of mine when we've done all that.
Can some of y'all help me with this? And don't touch the telescopes, please. Yep.
This telescope's much bigger than yours.
Yeah. What do you need? Lock those in. I tighten them.
I knew I was having trouble in and out of this chair, but the dang on support broke.
Oh, no.
Put some flag on it.
Hello, how you doing?
Good. How are you?
Fine.
Good to see you.
Yeah. Y'all camping out, huh?
Hi.
How you
Do you
doing?
remember me?
Oh, yeah.
Nice to meet you again.
He was sitting in the corner, I was sitting like on one end of it.
I didn't know that.
I said, you want me to knock you in the head? And my belt was laying on the couch between us, and she kind of got the end of it and flicked it towards me, going like, pick it at me. And when she flicked it, was just enough to make that buckle fly up and hit me in the eye. Oh! I said, I want to hit you in the head now.
Is that what you're telling people?
I said, I called the cops on you. I got him.
Yeah, it may have been something else. Yeah. I don't think it was a buckle.
It's sore to me, it hurt. Brought tears to my eyes.
Okay.
Hey, there's one of the faces of the moon. It's on your paper.
Get jarred around.
Don't leave each other, guys.
I don't know how, well, I've still got my shipping box and all the foam
Hey,
and
Jesse,
stuff, but I don't know if
You might want to
these
try
other
to get
people have
everybody
it.
something.
Yeah. Yeah, that worked fine, with yours there. But I was thinking, depending on how many, and you'd probably cost you an arm, to rent one, and
To rent the U-Haul?
Just that four, that's enough.
$44?
that's
I
not
don't
too
remember.
bad.
I don't remember.
I think it was $44. And that was like a 5x8
Yeah,
and 5 foot
that'd
wide.
be plenty, yeah.
Yeah, that's more than we need. Cause
Yeah. It's too bad they don't make one with shelves in there.
Yeah, I know.
So we could, like put them up on a shelf and latch them in.
Yeah. What I was thinking was that if I can find them, I got some old,
Why are you playing? You're not
not toe straps, but ratchet straps. So we take and bundle everything together.
Yeah.
And then if the sides of the trailer have somewhere we can hook the ratchet strap to, just ratchet strap it all to the back of the trailer.
Yeah.
Except for the ones that the stuff that can't be,
Right. Well, it's probably not going to have that many people going, and you probably not have to worry with it.
What is the Milky Way? Anyone know? The galaxy we live in, right. Now, why do they call it, how did they get the name Milky Way?
Because it looks like a string of milk.
Well, when you look at it, the sky looks kind of milky in that area, right? Now, what I'm going to talk about is why does it look milky? Anybody know? Anybody want to take a guess? Why does that part of the sky look milky when you look at it? And what are we looking at? The reason it looks milky is because when you look at that part of the sky, you're looking into the plane of the galaxy we live in. Because everybody knows the galaxy we live in is a spiral galaxy, right? And we're on the outer edges of one of those spiral arms. Actually, we're in the Orion spur, right? We're in a little spur that comes off of one of those arms called the Orion spur, right? Now, when you look at the part of the sky that's darker, that's not milky, you're looking out of the galaxy, either up or down, out of the galaxy, okay? So there's not as many stars. When you're looking at the milky part of the sky, you're looking into the galaxy. You're looking into into the arms or towards the center, depending on which direction you're looking. So therefore, there's more stars, so the sky looks milky because there's more light in that area. Everybody understand? So basically, if this was the galaxy, right, and it would be kind of shaped like this, how it's thinner where at the edge of my finger, and then it gets a bulge in the middle, right? So when you're looking at the darker part of the skies, you're either looking this direction or this direction, out of the plane of the galaxy. So there's not as many stars, hence not as much light. When you're looking at the Milky Way, you're looking into the galaxy, looking along the plane of here. So you'd be looking like in this direction. Therefore, it has more light. That's why it looks milky. Now, in different cultures, they call it different things. Like in Chinese, they call it Qinghe, right? Which means star river. The Indians had kind of same names for it, either rivers or stuff like that. But everybody recognized that it was a special part of the sky, you know, different from the rest of the sky. Not all of them understood exactly what they were looking at, but they did understand it was something special they were looking at. Any questions? No?
Mom.
You want to go with Mom? Okay, go. Now, I know Ben, when he went to you guys' meeting, he talked a little bit about the motion of the planets, right? So, which direction do the planets move? Which direction do the planets move?
Anybody remember?
Anybody remember?
No.
Okay, which direction does the sun move?
It doesn't.
Yes, it does.
Okay. Good point. Which direction does the sun appear to move?
East to west.
East to west. Now, why is that? Now, but everybody's right. You're right. The sun doesn't move. What causes that motion? That apparent motion? Back in the back. Yes.
That one?
Go ahead.
Because when the Earth moves, it seems like the sun moves around the Earth.
That's exactly right. It's not the sun that's moving, it's us that's moving. So as the Earth rotates, and we rotate with it because we're on top of it, or on the surface of it, it looks like the sun's moving. But actually the sun is staying in the same relative position, and we're rotating underneath it. Okay. The planets, same way. Now the planets do have motions themselves because they do go around the sun just like we do. But the motion that we recognize and the motion that we see at night is not because they're moving, because of the rotation of the Earth. So they move east to west also. Go over there and go with Mom and Dad.
No. Come here, Calvin.
So everything in the sky moves east to west, just like the moon. You know, earlier it was down closer to the trees, and it looks like it's moving higher in the sky. You know, as we sit here long. And there again, yes, it does have some motion because it does orbit around the Earth, but the motion that we recognize, the motion that we see as apparent, is caused by the rotation of the Earth. So which direction do the planets move?
East to west.
And why do they move that direction? Someone?
Because we're spinning on an axis.
That's correct. Yep. All right. What else we got to talk about here now? And I think Ben went over the parts of the telescope with you guys, correct? And he went over some of the differences and similarities in the telescopes, right? All right. Right. Like I said, he didn't have any visuals. Tonight we do have some visuals. If you want to take a notice, we have 3 telescopes set up here, right? And all 3 of those telescopes look different. All right? Now, all a telescope does, what we call telescopes sometimes are light buckets, okay? The purpose of a telescope is to gather the most amount of light and funnel it to your eye. Because the more light you can gather, the more detail that you can see in something, okay? That's like when you see those beautiful photos from telescopes or from the Hubble Space telescope or any telescope, and you see those beautiful photos and they have all that color in them and they have all that detail in them, but then you look in the telescope and it looks nothing like that. And the reason that is because when to get all of that detail in those photos, that telescope actually looks at that nebula or that galaxy for a long time, sometimes hours. It sits there and just looks at it and gathers more light and more light and more light. So the
What?
what?
Uh-huh.
I don't know. Go sit with Mama, darling. Okay. So the more light you can gather, the more detail and the more color and all that you can see. So the first difference in these three telescopes you see here is all of them are the size, they're round, okay? When you hear someone talk about the telescope, you'll hear them say an 80 millimeter, or you'll hear them say a 10 inch, or you'll hear them say a 6 inch, something other like that, right? When they're talking about that, they're talking about the size of the primary mirror or the primary lens. Now this is a reflector telescope, okay? Now, when I say reflector, the reason it's a reflector is because the light comes in from, say, from the moon, right? It comes in and it travels down and it goes to the back of this telescope, right? And there's a mirror on there. This is an 8-inch, right? Now, when I say this is an 8-inch scope, I mean the mirror, which is the primary light gathering tool, in the back is 8 inches. Okay? So the light comes in from the moon, goes to the back of this telescope, reflects off the mirror, comes back up to the front of the telescope where there's another mirror, because the back mirror is shaped like a concave. Okay? So it focuses the light from this small mirror up in the front, and then it bounces back out and it comes out the back to the eyepiece. Here. Okay? So this is a reflector telescope. This is a refractor telescope. And this is a, what size is this one?
6 inch, I think.
90 millimeter maybe?
There you go.
Okay. Now, when I say 90 millimeter, here what I'm talking about is the size of this lens here in the front, because the lens in the front of this one is your primary light gathering apparatus, okay? But now this one is a refractor. Now, refractor, what's refracting? Anybody know? If you reflect light, what does it do? If something reflects light, what does it do? Bounces off of it, right? So hence, this is a reflector telescope because the light comes in, bounces off the back, bounces off the front, and goes out the back of the telescope. So it's a reflector. What's refract mean?
It
soaks it in. It bends. Okay. So if the light comes in like straight like this, it bends it. That's how it focuses it, right? It refracts the light. Baby, go back over there. Come here. So with this one, there's multiple lenses as you go down this telescope, okay? The light comes in from the front. The first main lens focuses a little bit, then it comes on down. The next lens focuses a little bit, comes on down. The next lens focuses it. Finally, it comes out the back to your eyepiece. Darling, go over there with Mama. Go over there with Mama. Go with Mama. Alright, so now we have a reflector telescope and we have a refractor telescope, okay? Now the third telescope over here is also a reflector telescope. A little bit different than this one though, okay? But still it's a reflector because the light comes in the back, bounces up to the front, then another mirror bounces it sideways to come out the eyepiece, where the eyepiece on this one is on the back of the telescope, right? Here. On this one, the eyepiece is on the side of the telescope, here. So the light comes in, down to the primary mirror. The primary mirror focuses it up to a secondary mirror here. Then that secondary mirror bounces it sideways and out to your eyepiece. Okay. Now this is called a Newtonian reflector. Okay. That one is called that's a Schmidt, right? Cassegrain. And it's just, those are named, Isaac Newton, he's the one that came up with the idea for that kind of reflector telescope. The Schmidt Cassegrain, somebody named Schmidt and Cassegrain, I don't know exactly, I don't know the whole history behind it, but it's who developed the initial one.
Cassegrain telescopes are telescopes designed like this. They don't have, there's a lens in the front of this telescope that Schmidt corrector. He invented the lens that goes in front of this. Cassegrain actually, the rest of it he designed. So that's the Schmidt Cassegrain.
Now there's another difference in these three scopes here. You have now don't pay any attention to the scope now. Just look at the mounts they're on. What holds the scope? Okay. You have this mount. Here you have a little bit different one, and over there you have a third one. Okay. So that's another difference in the telescopes: the way they track, the way they guide, the way you point them. Okay. This one's what they call just an alt-az. It's altitude, up and down, and azimuth. It rotates, okay? This one, actually, you can line it up with the sky, and it'll track with, as something rotates, it'll stay on it, okay? But it doesn't, one of the advantages it has, the alt-az, as something, as you look at something, if you follow it across the sky, it will appear to rotate, okay? And that's because of the way that it tracks. This one takes care of that, doesn't do that. Okay, this is called an equatorial mount. You line it up with the equator of the Earth, basically, and the North Star and north and everything, and that's how it tracks across. That one over there is called a Dobsonian mount. Okay, and it's just another a man named Dobson developed it. It's a very simple, very easy. You don't have to align it. It doesn't track anything like that, but it's very simple, very easy to use. Anyone can learn to use it. So that's the biggest differences in all these telescopes here. You know, the biggest difference is the way they gather the light, how the light's focused, and then the way they track through the sky. Any questions? No? No, easy crowd. Alright, what do we got to talk about next? Let's see here. Talked about that one. Mine will swim. Let's see. Okay. Let's say describe the proper care and storage of telescope binoculars both at home and in the field. That's pretty simple. Like pretty much anything that you have nowadays that you want to keep them dry. You don't want it to sit in the sun. You don't want it to be out in the cold. Basic room temperature. Keep it dry, out of the sun. You want to keep the dust off of it because the dust will actually degrade the lens or the mirror. As the dust sets on it, when you try to, and it's not the dust setting on it. Actually, if you have like a dirty mirror or a dirty lens on a telescope, sometimes unless it's really bad, it's better just to leave it alone. Because the removal of the dust is usually when the scratches happen. The dust falling on a mirror or the dust falling on a lens doesn't scratch it. It's when we go and we try to wipe that dust off, that's when the mirror or the lens gets scratched. So if you have a telescope or if you have binoculars or anything like that, and it looks like it's dirty, sometimes it's better just to leave it alone. If it's really dirty and when you try to look at something, you can't see what you're trying to look at, it's that dirty, then come to one of our meetings, come to a meeting of a club like ours, and go to someone who is experienced with cleaning. I have a telescope at my house that's dirty, that needs to be cleaned. But I won't even do it myself because I've never done it before, and I don't want to damage the mirror. Because once the mirror's damaged, it's damaged. You can't correct that anymore. Now, out here in the field, the biggest thing we try to do is set the telescope up in a way so as we move around it and we walk around it that we don't trip over it. Because if we trip over it, we get hurt, and also if you knock the telescope over, it gets damaged. Now, down here in the southeast, another thing you have to worry about is the dew. Starting here in about another month or so, another few weeks actually, when we take our telescopes out at night, they will get very, very wet sometimes. So sometimes you can cover them up with a sheet, cover them up with a towel, or you can take a blow dryer or something like that to dry them off, to keep some of the water off of it. But that's the biggest things we have to worry about out in the field. Obviously if it rains, I've got to keep them covered up, something like that, keep the dew off of them. Sometimes when we're out in the wintertime, even ice starts developing on either the primaries or your eyepieces or your finder scopes will actually start getting ice over them. Where you get a little bit of dew in the air, or frost, and then the ice will start developing. All right. I think
if you have binoculars, most of them come with the covers like this. So always make sure when you finish using them, you put the covers on them. That helps protect, keeping the lens from being scratched.
And same for telescopes.
Same for telescopes. Yeah, keep the covers on them.